Finish making it because, well, life. But two of the pages are virtually identical to the understanding checks, different problems, but same questions. I'm not trying to hide that. And that accounts for, well, there's 3 short answer and then those 2 sets of questions. And that accounts for the first 14 questions on the test. The next 11 are multiple choice. You still have to justify your answers, but 11 of the questions are multiple choice, and then I think there's 4 more that are free response. But I have designed the test so that it can be all calculator, so that you can use it where you need it. Yes, ma'am?
It would be just like the
So there will 2 pages of the test are just like the last understanding check and the front page of this understanding check. But you're gonna have to show me evidence. So like when I say first 2 pages, I mean front and back. 1 page front and back, and then there's a 2nd page front and back. And it's all calculator, so I'll just give you the whole thing from the get-go. You show me what you know. Okay? So, not trying to hide it from you. I'm telling you what's on the test. It's logarithms, it's inverses, it's some exponential equations, it's identifying some growth and decay. I will say, to make your job easier, I did not put anything with the compound interest formula on there, so you do not need to study that. Good talk. Alright, yes ma'am. You going right now?
Yes, because we have another one tomorrow, and I check out early. I check out today, so I'm not gonna be able to go in there today, and I'm not gonna be able to make it up. It's just too much, and then next week is it.
Yeah.
It's from Miss Brown.
Here you go.
You want me to take this?
Leave it there, I'll make scans of it, come back for it, so that I have
I'll
the
come back before I
scans.
check out, whatever.
Right, so I'll make scans of it, and then I'll post the video on YouTube so you can take what notes and learn what you need to ask questions about.
Okay.
Alright, so, there it is. Please ask all the questions you have, but pay attention to your details as we go over this understanding check, right? Quick question, would it help, I know it would make it harder to see your paper, but would it help you for me to turn the lights off so we can see the board a little bit better? Yeah. So we'll do that for the understanding check. Yeah. I don't know, then we're going to get back to the book a little bit. By the way, all pencils off the desk. I do not want to see a pencil on the desk. It is way too tempting to write stuff down that we're not supposed to write. So, hey, leave the pencil off the desk. Only pens on desk. That is it. Yes, sir. Can what? Close it? Too much light coming in? Just can't. Well, you can't see the board from there easily? I honestly have never tried that. Is that enough? Okay. So please note some of the details that we missed. We need to be careful with our points. I think I saw a lot of us nicely transposing our points, but notice, what vertical line did I not go past when I graphed this?
Oh, what vertical? I'm tripping over.
What vertical line is that? X equals? Say again. This? I'm talking about this vertical line right here. This graph did not go past it. But first, let me answer. Let's talk about this. What line is this? Yeah, but what line? X is equal to? Oh, this is y equals x. What number is that? That's x equals 1. Look at your x values, 1.5, 1.25. You see how it's getting closer and closer to that 1 in the x value. The other thing is, what's the horizontal asymptote right here for that exponential? Y is equal to 1. So what is the vertical asymptote? The logarithm cannot go past. X is equal to 1. We need to pay attention to those details. So correct that on your paper. If you went past that, use your pen to draw that vertical asymptote in there and explain why it did not go past that line. Okay? So this is the one issue with turning the lights off, is it's harder to see the paper. Yes, ma'am? That's good evidence understanding, but it would be just a very slight procedural error. So like with justification of 3.5 or a 3 plus. That's pretty good, but we need to pay attention to the fact that it's going to get almost vertical at that point, right? So update that for the test. Remember, guys, yeah, it's not completely straight, but it is very, very, very close straight down. Please remember, guys, this is a learning activity, learning from our mistakes so that when it comes to the test, we don't make those mistakes, that we understand these concepts better. Okay? So please note, I did justify this. I reflected over the line y equals x and I transposed my inputs and outputs. I really should have made the note about this vertical asymptote to really get to that 4 plus, but I justified and explained why I did what I did. And I did label those points. Okay, so what questions do we have about that inverse function? That inverse graph. Now I do want to point this out. Notice how we did not have to restrict the domain of this function to get the inverse. Why is that? Which test? The original function passed the vertical line test, which told us it was what type of function, or it tells us what type of relation. The vertical line test tells us it is a function. The horizontal line test is telling us that the inverse is a function, right? What do we call a function whose inverse is also a function? It is invertible. We got to know that vocabulary. That was from the first half of this unit. So we have an invertible function here, which is why its inverse is also a function. Make sure you note those kinds of things. Okay, can I go to the next question, or do we need a little bit more time to write notes? So here are my responses for numbers 2 and 3. And we can talk through these for sure, but notice how I talked about how the range was approaching that asymptote for part of my justification. Just making a note that, hey, my domain is my x and my range is my y is more evidence of understanding. But domain and range for f of x is here. And then notice what happened to my domain and range when I got the inverse. What happened? The domain and range switched from f of x. So every piece of this that you identify correctly, even the idea of domain and range switching, if you note stuff like that, that's evidence of understanding. Even if your domain and range here is wrong, but you correctly switch your domain and range, that's evidence of understanding. Yes, ma'am. Say again.
I forgot this. Hold on.
Okay.
Oh, yeah. Okay, so I'll put transpose instead of just saying switching. Is that all right? That bad?
It's not bad, but remember, so like what happens is we transpose these inputs and outputs on the graph, which cause the domain and range to switch. Transposing is talking about individual point values are switching. And so the domain and range switch, as far as I'm aware. I won't count that against you or anything like that, but that's how we've always talked about it. That's the difference. Any questions? Why is it a 1? For this range right here? So look at the graph. See how it's coming down right here and it's flattening out? What's this y value right here where it's flattening out at? 1. Does it ever get below that 1? Nope. So we've been mostly looking at it approaching that x-axis, but I did tell you, like, we have to pay attention to what line is it approaching. Notice I kind of drew in a dashed line here to see, oh, that's y equals 1. That's something that we want to make a note of. questions, comments, concerns? That answers everything, Eliza? And remember guys, that's why right here, when I look at this graph, it's the same thing. What is the lowest x value for the domain? 1, right? Now we'll also point out, if your domain and range down here match the graph, that's understandable, especially if you justify it, right? So pay attention, like update it to be the correct thing, but be aware I read with errors. So if you made a mistake on number 1, but you do number 3 correctly based on that mistake, I am understanding of that. Again, if you do number 2 incorrectly, but you correctly switched your domain and range for 3 based on that, I'm understanding of that. So there's lots of ways to show evidence of understanding. Ma'am. So infinity comma -1. So one thing to remember is when we do interval notation, it always has to be a minimum and then a maximum. Infinity is way bigger than -1, right? Does that make sense, Haley? Infinity is bigger than -1, so it cannot go that way. You could have done -1, but remember that's not a -1, that is a positive 1. Positive 1. Right, so the minimum x is 1 for the inverse, the minimum y is 1 for the original f of x. Any other questions that I can answer to help us understand our domain and range better? Going once. Going twice. So, Marshall, you're good with your updates? Number 4, what are the asymptotes of each graph? So notice, this is a big part of what informed me for my domain and range, what informed me of the graph for this function for the inverse. We want to pay attention to those asymptotes. What would our function be approaching? What line is it approaching at an infinity? Notice, what did I use to somewhat justify the end behavior, right? That end behavior, literally what an asymptote is what the function approaches at an infinity.
What about you wrote it?
Huh?
What about I wrote it?
If you wrote that detail?
Like I wrote the line the function approaches at infinity.
I mean, that's evidence of understanding. Is that all you wrote?
Yeah.
Okay, but I'm asking what are the asymptotes of these graphs? So that would probably be a 1 because it's a starting point, right? Like you understand. Oh, you wrote this right here?
Yeah.
Oh, okay. That's if you noted something on the graph to help justify that, that'd be a 4 plus even, without this note or noting maybe this on the graph at 3D plus. So very strong evidence of understanding.
We're just writing, well, the 1x.
So y equals 1 and x equals 1 and that's all you wrote?
Yeah.
No justification whatsoever? If you don't justify anything, it's just a 1 plus. But learn from that for the test, right? Guys, you always need to tell me why. Why are you thinking that? That's what I'm looking for. So learn from that and improve for the test. Jayla, good? No questions? Making sense? Grace? Cool. Ready to crush it this afternoon? / evening? No? We scared? A little scared? Don't be scared. Go out there and crush it. Alright. Any questions? Going once? Going twice? Sold. So I put number 7 next. There's a lot written here. Please notice in the pink, look, in the pink is my end behavior for f of x and for the inverse of f of x. So what is this blue doing? That's explaining why. That's all that is, right? So here's my end behavior. Here's the explanation of why for that end behavior. Here's the end behavior for the inverse of f of x, and here is y.
Let's get 6.
I'm going to go back for it, 5 and 6. So here's the reason why I did that. What helps us define the asymptotes? What helps us identify or define the asymptotes? The end behavior. So I did those together to show how they go together, right? So end behavior and asymptotes are very, very, very tightly connected. Yes, Tevin.
What does it approach in the blue approaching?
Approaching the asymptote, right? That's the whole thing is, as x goes to negative infinity, that y approaches 1, the asymptote right there. It's not going to get to that asymptote, but it's going to approach it. And that's how we define an asymptote as well.
Right, so the inverse, okay, so F2 -1 is the inverse of X.
Say that one more time. You talking about this notation up here?
Yeah, that's the inverse.
Anytime you see this notation, not only does it mean it's the inverse of that function, it also means that that's the inverse function of f of x. So the inverse is a function. But that superscript in -1 tells me the inverse function of f of x.
Okay, so why did F of 3 up, the F3 of X right there?
Say it one more time.
Yeah, F3, you know on the graph?
Oh, that's because that's how it does it on the calculator to identify function 1, function 2, function 3. But that's why so if you look at the very top, see how I defined f of x as 2 to the x plus 1? That's this right here.
Yeah.
Sorry if that was causing confusion. But that's all that is. Any more questions? Quick show of thumbs up if you're ready to move. Thumbs down if you need just an extra second or so. Okay. So just a little bit more time. Okay, looks like we're ready. Tevin, you're on still writing. Okay. So here's number 6. Did I not do 5? There it is. So here's number 6. It was hopefully a very easy one. Even if you did not get this graph 100% right, you should be able to see that y-intercept crosses the y-axis. Does this function ever intersect the x-axis? No. Okay? So keep that in mind. And so the inverse of f of x has that x-intercept. Its inputs and outputs are transposed. What's up?
So,
Drown? Were you about to say a question or no? Okay.
So, yeah, I put that 2 as my asymptote, not knowing.
You put the 2 as the asymptote?
Yeah.
Yeah, be careful about that. Notice the 2 is the y-intercept, but it definitely goes below the 2. So it's not approaching the 2, it goes past the 2 and goes below it to that 1.
So,
That would be part of our evidence, wouldn't it? So that could be like that would get up to like a 4 plus. You can literally, if you would just circle maybe the points here on the y-axis and the point here on the x-axis, that's evidence of the intercepts. But one of the big things we want to always remember is what's the relationship between functions and their inverses? The inputs and the outputs transpose, right? The idea that the x and y switch, and that's a stronger evidence of understanding. So you got to remember, like, it's not right or wrong, and I feel like that's still a mentality a lot of us have. It's not just, hey, it's right or it's wrong. It is, what's your evidence of understanding? How much understanding are you showing me? So you can still show me understanding without it being perfect. I would say for the most part, all of these would be at least a 4 or a 4 plus, but you don't even have to have a 4 plus to earn a 100%.
What?
I think an average of like 4 or a little bit below 4 is 100%. Okay, questions, comments, concerns?
Can you put it on the understanding check before the test or after?
Usually before. Last test, I didn't get your second understanding check grade in before the test, but I updated everything afterwards. So I try to get it up before, so if I can get everything graded today, that'll be okay. Okay? Yes, Traylon?
If you just put 0 and 2 and 2 0.
So remember, I need some evidence, some justification, right?
So you want us to do, right, like inputs, outputs, transpose?
So that would be evidence for why these switch here. But like evidence for why these are my intercepts, could you have just circled the y-intercepts right there on the graph
What if,
and the x-intercept right here on the graph to show me that you understand where those are coming from?
yeah, I did that.
Okay, then that's evidence of understanding,
Okay.
right? So that's something that I would accept as evidence of understanding. It's not like a 4 or a 4 plus, right? Because a 4 literally means clear, consistent, and convincing evidence. Like You're knocking it out of the park, you're getting all those details. That's why I made this note about my inputs and outputs transposing for that inverse function. Okay? Here's number 5. This one I think might be a little bit more complicated. Please notice this is my final piece over here, but I started with this. So I will point this out. Let's pause for a second. If we're writing an inverse function, what should we definitely have for the inverse of an exponential? So f superscript negative 1 of x equals, what should we 100% see for the inverse of an exponential? How about a logarithm? Right? If it's the inverse of an exponential, you should definitely, without showing all the inverses, I'll walk through those steps in a second, but you should definitely have a logarithm. What should be the base of that logarithm? It would have to be at least a base 2 of x. And if you explain something like that, that's evidence of understanding. Now, the full steps here are, to get an inverse function, we need to solve for x. We need to use the inverses, right? And so 2 to the x is the first operation. Then what's happening after 2 to the x? We are adding 1. So I subtracted 1 to get started. The last operation being done is the first one I want to undo. And so I use color coding here. I don't know if you picked up on that, but what I got was y minus 1 equals 2 to the x. Well, what's the inverse of an exponential? Hold on one second, Haley. What's the inverse of an exponential? A logarithm. And so I took a log base what of both sides? Base 2. That's it, right? If I have that exponential to solve it, I need to use log base 2. And that's why it's a different color here. Notice those inverses cancel, and I was left with an x equals log base 2 of y minus 1. I use my inverses, and I know that a logarithm is the inverse of an exponential. There will be one question like this, yes. That is not the entire thing, but if it's only one question, that's not going to make or break you. Okay, pause. If there are 20-something questions on a test, and one of them is write the inverse function, is that really going to make or break? The answer is no, because you could still easily make an A completely missing that question, so one question is not going to make or break you. We got to stop stressing out about not being able to get every single one. Show me everything you know. What's up, Haley?
Oh, I had put negative
You put negative 1 plus y?
no, yeah.
That's equivalent. I'd have to check it, but I would update it this way. Notice, so like you subtracted 1 from both sides and put the negative 1 first. That's fine. As long, if you had negative 1 plus y and you took log base 2 of both sides, you would have the inverse. I will point out, notice I did convert that to my inverse function notation at the end there. One question ain't gonna break you, Shania. If you understand the rest of this, you'll be fine. But I'm sorry you feel that way. Alright, final questions before we continue. Going once, going twice, and sold. So here's 8 and 9. Number 8, we should not miss. This should have been a gimme. I've talked about this, I can't remember how many days in a row. Inverses of functions are reflections across y equals x, and the inputs and outputs transpose. Ooh, I actually forgot something when I made my notes. If I want to relate the features analyzed above, what should I note about the features that we analyzed above? Like domain and range what? Switch, right? The x values switched with the y values in that in behavior, things like that. Yes, Naisha?
I put an equal sign instead of whatever that is.
Where?
On number 9. Look.
Oh, we'll get there in a second. So this would not be a 4, what I originally wrote. Etc. switch, right? So domain and range, in behavior, intercepts, all those things are switching. Asymptotes, right? If it was a y equals, the inverse would be an x equals. Naisha, it's not exactly equal to. Remember, it's only approximately equal to. Say it again. E? Well, E is an imaginary, or it's not imaginary, it's an irrational number, and so it's approximately equal to, not exactly equal to, but approximately equal to 2.718 to a so on and so forth. Okay? So 2.6 is the exponent for base 4. I will go ahead and tell you, you've got to be able to explain to me what a logarithm is on the understanding check, or on the test. Say again. It's an exponent. And so what that logarithm equals, that's an exponent.
So what if you just put a logarithm into base raised to the exponent?
I mean, that's evidence of understanding, but tell me, and so that's clearly addressing what a logarithm is, but this, you have to address this as well. Tell me why this is approximately equal to 2.6. Well, actually be careful. A logarithm is not a base to an exponent. The logarithm itself is only equal to the exponent. We can rewrite it as an exponential form, so 4 to the 2.6 is approximately equal to that argument. But the logarithm itself is only equal to an exponent.
How do you get 4 to 6?
So what's the base of my logarithm? 4.
Oh,
And what's a logarithm equal to? An exponent. So base 4 to the exponent
oh.
is equal to the argument. Remember, the argument is the input of the logarithm, which is the output of the exponential. So now you got a question? The logarithm is the inverse. Well, so one thing to be aware of here is we don't have an exponential function, we don't have a logarithmic function, we just have a logarithmic equation, right? So we wouldn't be talking about the functions as much here. They are related like that. But what is a logarithm? It is an exponent. So a logarithm on its own is an exponent, and we can get a function out of that as a result, right? So if I have log base 2 of 4, that equals 2. Log base 2 of 2 is equal to 1. Log base 2 of 1 is equal to 0. So I can take my inputs and outputs together to create that function, right? But the logarithm is the exponent. I would have to look at it more. Focus on improving our understanding, not just the scores. All right, last 3. So I identified the base each time, I identified the exponent each time, and then I solved for n.
Can you do the last one?
Okay, we can talk about the last one. That last one, right? What's the base is n, the argument is 216, the exponent is 3. So base n to that exponent is equal to 216. So that is n cubed. What is the inverse of a cube? Not a square root, a cube root. So that's what I did there. That makes sense now? And so that's why I let y'all have a calculator, is for that particular problem actually. The calculator wouldn't have helped too much on the others, maybe on number 11, but that's the thing. Once you get your equation in different form, continue thinking about those inverses. Well, the cube root. So you would need to hit control and then that caret symbol that does an exponent. You see where it has a root that's any root? And you can put that 3 in the crook there. Alright. Questions, comments, or concerns at this point? Go for it, Shania. Hold on, let Shania first and then I'll address your question, Haley.
When I was 12, I got the base, the argument, and the exponent. I just didn't have time to do the equation, so we didn't.
partial understanding is what's shown. You probably could have found the answer, but remember, don't sweat about what happened in the past. Let's make sure we can do it for the test.
So what do you mean?
It means I will score it when I look at it.
It needs
It's-
to be great.
You're fine.
But I didn't crazy.
Right, but here's the thing. If you think about it, zeros and ones are little to no evidence of understanding. Twos are limited evidence of understanding. Threes are clear evidence of understanding. And fours are clear, consistent, and convincing evidence of understanding. I would say that's limited evidence of understanding that you have shown me, but that's still a decent score. It's a good start. Especially if you show me information on 10 and 11, you'll be okay. All right.
Yeah, I think it.
Yes, ma'am.
I just put arrows and you said they just try to line it out like you did.
That's fine. Yeah. This is just a little bit cleaner, easier to see.
I had just wrote it instead of explaining.
Okay. I'll look at it. I'll score it when I look at it. All right, what are your final questions before we get to some more practice with these ideas today? All right, Ethan, can you hit the lights for me? Go ahead and get your textbooks out. Who does, right? We're going to go to all the pieces of the puzzle. We already started on this, but it's M3-171. We're going to work with some logarithmic equations to help us practice that for tomorrow. I think we're actually on, we already did some of these, didn't we? Yes? Okay. I'm going to talk about a couple of details here really quickly. 175. Cody, can you place all the things for me real quick? Well, I have a move off the theta meeting in the morning. Sorry. It's on there. I'll be here. I just have, it's here in my room that I have Math Honor Society. I'll try to wrap it up early. Jacoby's coming for him. Yes, please do that. What? You good? That's alright. Tevin, what's yours? I was like, how did you do that already? Thanks, sir. Alright, so let's talk about a couple of things to get us into the right mindset of solving logarithms. 175. Why are you uncomfortable? Jacoby, 3 more pins right there. Okay, so 2 details that I want to remind you about. Okay, first things first. When I look at this logarithmic equation right here, what's the base? That's known as which logarithm? Common logarithm, which has a base 10. It's understood, okay? So we can quickly convert this to an exponential. What is the base for my exponential? 10. The exponent is? And that is equal to? 10. Because it's defined that way. The common logarithm is one of those things that legitimately is so common that instead of writing the base 10, we just can write it without the base. So if you ever see a logarithm without a base, it's understood to be base 10. It's very similar to the idea that this square root of x is understood to have an index of 2. But because that's the most common square or root we do, we don't write that. If you have a cube root though, you have to write the cube root. If you have a fourth root, you have to write the 4 there. But the square root, we don't write that 2, it's just understood. What are you asking?
I was writing that they want.
Equivalent.
Yeah.
They're not just equal, they're equivalent, right? They mean exactly the same thing. Okay. Sir?
No, where you get negative?
It has a negative 3 right there.
Looking at A.
So, Marshall, if there is no base written at all, we have defined that to be understood as base 10. That's just, it's a common logarithm, okay? So if it's ever a different base, you have to write the base, but if it's base 10, you don't have to write it. Okay, now I will say this, and I mentioned this yesterday, can you write the base 10 in there? Yes, I ain't gonna sweat it. Be aware though, if you ever see a logarithm without a base written, it's understood to be base 10. The other thing I wanted to point out and show you is this. We can also use inverses to rewrite these equations. What is the inverse of a logarithm? An exponential, not just an exponent, it's with a variable exponent. So what I can do is, I can do 10 raised to this exponent. Because these are inverses, what's going to happen with the 10 and the log? They're going to cancel. Notice that I'd be left with n equals 10 to the negative 3. Sometimes using the inverse like that is going to be an easier way to do it than just rewriting. Okay? So that's just a thing to be aware of. So we already did several of these problems yesterday. I decided to not do these, don't sweat them. This is what I want to talk about. So this is on page 182. We're about to get some practice problems at the boards, but I want to point these things out with notes. So this is a always, sometimes, or never set of problems. And this is good background information, always keep in mind. The value of a logarithm, that means the output, okay? So the value of the logarithm, that's my output, or what is the output of a logarithm always? Okay. So value is my output, or what again? It could be a y, but if I evaluate a logarithm is equal to an exponent. Yes. So the output or the exponent. So the value of a logarithm, that is the output or the exponent, is blank equal to the exponent of the corresponding exponential equation. That's an always, right? Literally a logarithm is an exponent. So I kind of gave that away. But it is always 100%. That's something you need to keep in mind. The value of a logarithm is always equal to the exponent. The argument of a logarithmic expression is always, sometimes, or never a negative number. Sometimes, okay, so like I could do log base 2 of negative 4.
That wasn't work for me.
That didn't work for you. Oh. So let's think about this, right? It's supposed to be an exponent. So how would I rewrite this as an exponential? 2 to the x is equal to, can 2 to the x equal a negative? Think about your exponential graph. 2 to the x. Maybe an imaginary. We ain't studying imaginaries with exponentials. I've actually never studied imaginaries with exponentials. I'd have to explore that some more, but that's a possibility. But regardless, that's a good thought. But we do define, I'd have to look into it. I'd have to look into it. What's up?
I forgot.
Okay.
No, when do you post this video on YouTube?
Day of. So like it'll be up before 4th block today probably. Or during 4th block. That's why I usually record in this class so that I can put the videos together. I ain't got time for that. So please note right here, okay? Does this exponential ever go into the negative y values? No. So can the argument, which is my input of a logarithm, notice there's my inverse, can the input be negative? Look at that logarithm. Can that input be negative?
No, because it's going to the right.
Remember, input is for my domain or x.
Yes.
Do we have negative x values?
I wouldn't say this, I was saying this.
Oh, I got you. Please note, domain, do we have negative x values? No. If you're looking at the y, remember that's the exponent, right? So, the argument is never a negative number. The value of a logarithm. Oh, you might want to take some notes. I'll wait a second. Okay, the value of a logarithm is blank equal to a negative number. Sometimes. We can see it right here. These values would be negative, but these values of the logarithm would be positive, right? Because an exponent can be positive, an exponent can also be negative. So we always want to remember that the value is my exponent. That's the output. The base of a logarithm is sometimes, always, or never a negative number. Is what? Never. Remember, we said, and we talked about it, the base cannot be less than or equal to 0, or the base, and the base cannot equal 1. That is true both for an exponential and for a logarithm. And it's true for a logarithm because it's true for an exponential. Okay. So I'm skipping 5 through 7, those covered concepts that we did not talk about. That's why I didn't fill those in. Okay, we're going to look into the next lesson, actually the third lesson. We're skipping the second lesson. It's going to help us practice what we've already done. Yeah, it's going to help us practice what we've already done.
Okay.
The third lesson, go ahead and jump to page 201. We're going to go to activity 3.2. Okay. So, this is where I'm going to quickly run down and make some scans. You can work at your groups or you can work at the vertical surfaces. I need you to tackle solving each of these 4 equations. Think through what you know to figure out these equations. That needs to be up there. Alright, so just a couple minutes. Work with each other on numbers 1 or 8 through A and B on numbers 1 and 2.
I'm like, where did you get
No, why would you go back to 8?
What's not even?
So what's the answer? The answer is right.
It is 8. No.
What did y'all talk
It's not 8. Grab a seat, let's talk about it.
You don't have to defeat somebody.
Okay, grab a seat, let's talk about these ideas, ladies and gentlemen.
Why is it 5?
Hey,
You want us to write?
No, why? It's not 8.
That is a
that mean
why.
that'd be helpful for you? Yes.
Dude.
Hey, Naisha, grab a seat, Haley, grab a seat. Alright, so, here's the thing. Listen, and I get this, but we need to pay attention. The issue that we're running into in group 5 that we want to learn from is they wrote the square root of 64. But what's the square root the inverse of? Square. Do we have x squared right here?
No, we got
No, we have 2 to the x. What is the inverse of an exponential? And I want to remind you, an exponential is when the variable is where? An exponential is when the variable is where? So in the, okay, notice this is an exponential. Is this an exponential? No, that would be closer to a polynomial, a cube. The inverse of an exponential, though, is a logarithm. And so, again, 2 ways to approach this. What base do I want for that logarithm? Base 2. What's my argument or my input?
64.
And that is equal to x. And when we evaluate that, when I look for the exponent is,
6.
okay? To help us with this, what we do want to also notice is, if I have 2 to the x, what's the inverse operation that I could take of both sides? Now what? Not a square root, because a square root's the inverse of a square. I don't have a square. What is the inverse of an exponential? Dividing is the inverse of multiplication. Okay, the inverse of an exponential. As soon as I see an exponential, I need to take a logarithm. But which base do I need on that logarithm? Base 2. Whatever I do to one side of the equation, I got to do to the other. So what happens to the log base 2 and this base 2?
Cancel.
They cancel, and I'm left with x. Does that look Familiar?
Yes.
So using that logarithm as an inverse will get me to the same point as just converting to a logarithm. But again, this method will be nicer in some cases. Yes? Now, this is in contrast to B. Could I rewrite this as a logarithm? Yeah. I could rewrite this as log base, well, right now it's log base y of 125 equals 3. So we would think what to the third is equal to 125? 5. But if I'm using an inverse, what's the inverse that I should use here? What's the inverse of a cube? Cube root, right? I wouldn't use a logarithm here. I would take a root, cube root. And then I would type the cube root in. The cube root cancels the cube, and guess what? What's the cube root of 125? 5. Does it give me the same answer? Use your inverses. Okay? So we want to pay attention to that. I will point out, too, or way easier, what does W have to be for number 2? Look again. We have log base 3 and we have log base 3. W would probably have to be 20, wouldn't it? If the logarithms are exactly the same. I will point out, what's the inverse of a logarithm to help us understand this? An exponential, right? So what would the base of my exponential be? Base 3 raised to this logarithm. Base 3 raised to this logarithm. Well, what happens with these inverses? They cancel each other out. So W would have to equal 20. So that's a way to see that using inverses. But again, if the bases are the same, the arguments have to be the same, if they're equal. If these arguments are the same, what do we know about the bases for them to be equal? The bases have to be the same. M would have to equal 4. That's it. Not too bad. Okay. So I don't want to use Todd and Danielle's strategy here. This is on, I think, the next page maybe, 202. I want to talk through the most efficient method here. I want to point this out. Well, actually there's a couple ways to do this. There's 2 ways, and neither of the ones I'm going to suggest are, actually I guess it does match one. How could I solve for x here? Because I'm going to tell you, does anybody know what exponent goes on 8 to give me 38.96? Same, I have no clue. Because I know 8 to the first is 8, 8 to the second is 64, so it's got to be somewhere in between there, but I don't know it. So what can I do to solve that exponential equation? I can convert that to a logarithm, right? So we got to keep in mind, logarithms are the inverses of exponentials. So what would be the logarithm that I would use? So log base 8 of that argument would have to equal the exponent, right? So how would I figure out what x is? I would put that joker in the calculator so fast. I don't know that answer off the top of my head. I love calculators. They're awesome. But you need to know how to find that inverse on your own. Okay? So fast. Put that joker in the calculator. You just don't believe it. Alright, so what is log base 8 of 38.96? 1.7. What? I would assume it's approximately equal to x, not exact. There's decimals after that probably.
It's numbers.
Oh, this one, this one.
It's 1.76 to 134.
Yeah. There's still, notice that it just continues that decimal. So it's approximately 1.76. Okay. Couple of details then. How could I use, yes ma'am? Well, yes, but notice it's literally just converting to a logarithm, which we've been doing. What's the other way that I could have done this? Instead of just rewriting it using a logarithm, what could I have done on both sides here? What's my inverse operation?
A cube.
Do we have a cube here? Remember, that variable is in the exponent. What's the inverse? What? It's a logarithm. The inverse of an exponential is a logarithm. So I need a log on both sides, but what base do I need for that logarithm? And whatever if I have inverses, they cancel. And so, does that look familiar? So,
Yes.
those are our inverses. I want to show you one though, why I recommend using inverses like this instead of just converting to a logarithm. Most of these will not be to this difficulty, but I do have one on there. I'll go ahead and tell you that. There's one. Like E here, this is on the Talk the Talk on page 204. And this is what we'll have to wrap up. If you have an equation, what's a strategy that you can always use to solve equations? Inverses. What is the first inverse I would use in this equation? The last operation happening on that x is adding 1. So I'm going to, from both sides of that equation. So 2 times 3 to the 5x would equal what? 54. Now what?
Minus 2.
Remember, those are being
Oh,
multiplied, so I can divide. You can use that reciprocal to divide, 1 divided by 2. So what is half of 2, by the way? 1. Half of 2 is 1. What's half of 54?
What?
Half of 54. Or 54 divided by 2.
27.
27. And so at this point, when I have just a logarithm, or just an exponential, I can convert to a logarithm. But I've been using inverses. When I have a variable in the exponent on its own, I'm going to use a logarithm. What's the inverse, or what base do I need on this logarithm? Base 3. Whatever I do to one side of the equation, I do to the other. So notice the logarithm cancels out that base, and 5x is equal to. Can I put log base 3 of 27 in the calculator? Yes, because I'm giving you a calculator the entire test tomorrow. Now, it is equal to 3. Yep. We got finals Monday, Tuesday. Last step. Divide by 5. X is equal to 3/5. Notice, to solve these equations, what can you use? Inverses. Use those inverses, ladies and gentlemen. Definitely feel like there's been some good learning today, but don't forget, what are all of you? Capable of more. That's why you gotta take the time to study. None of this pops into anyone's head randomly. You gotta study it. Are you feeling good? Thinking transcends all of life.
I wrap it too much. You got a dog? So you would rather be the dog?
Hey Grace, especially because I won't be able to give you yours tomorrow. Who is still in here? Sanaya.
You're not gonna be in tomorrow?
Grace isn't going to be,
Oh,
right? You aren't coming back tonight, are you?
I think I am.
Oh, okay.
We got to anyways.
Yeah, you can go ahead and have it. Now you should. But I meant to give these back to everybody today, and I just totally forgot. Good morning, Kason. Yes, sir. Good morning, Tristan. Yes, sir.